So let's do CH3Cl.
Let's make it easy. Just that way.
That's okay. That's why we're doing this. We're going to do lots of practice, okay? So, carbon has how many valence electrons?
4.
4. 1, 2, 3, 4. We have 3 hydrogens. 1, 2, 3. Okay? Chlorine, how many valence electrons? Has 7. 1, 2, 3, 4, 5, 6, 7. I'm just going to keep switching it up. Okay, so carbon is looking for 4 more electrons. Could we not say that hydrogen can share 1, hydrogen can share 1, hydrogen can share 1, and then chlorine can share 1, okay? So when we actually draw this out, and it's going to be very busy, mind you, okay? So carbon, will go in the middle. So could I show that?
Yeah. That's a super stacker combo.
Just wait for it.
Is there a name for it?
Yeah, super stacker combo.
No. Well, eventually we're going to talk about Vesper models, and then you guys are going to hate life, so yeah. Okay, so if I were to draw the structural model for this, carbon, 1 single hydrogen, 1 single hydrogen, 1 single hydrogen, 1 chlorine. Okay? Yeah, it's practice, okay? It's understanding how many of those valence electrons and how they're likely to work together, how it's going to go, okay? All right, let's get tough. Yay! Okay. Run. Okay. You guys try carbon dioxide. Yes. Okay. Carbon dioxide. So, what's the formula first? CO2 gas. Okay. So, carbon, start off with the one with the highest ability to bond. Okay, that's kind of the trick here. So carbon has 4 valence electrons, right?
Oxygen has 6, though.
Oxygen has 6, though.
I know how.
But there's 2 off. Therefore, there's 4 left over.
Okay,
The
so
oxygen can bond with each other. And then the carbon bonds onto
Why
one
can't one oxygen be on the top and one oxygen?
are you guys seriously having nerd battles right now? I think you are. I think you are. No, I know the answer. Okay.
This is why sometimes I say, like, mean. This is why I call you mean.
Okay. So, how about first, let's start off with bonding our oxygens to the carbon, okay? That's who likes to kind of take the center of attention here, okay? So carbon, let's do 1 oxygen here,
It's going to be a disaster.
and 1 oxygen here. It's going to be very messy, yes, yes, yes.
It makes sense.
Okay, so carbon is still looking for 2 other electrons. So this is what'll happen. And this is part of the predicting part of the whole premise of building these structural models. Let's say that those 2 can get together inside there. These 2 can get inside there. Okay? Yes.
I just said moving into refrigerator.
Exactly. Well, not exactly. I do mine.
Wait.
There's still most arrows.
Everyone gave me an answer. I don't know what's happening anymore.
Oh, I get it.
I don't.
Welcome to the Twilight Zone.
Okay, so each of these were missing an electron beside each other, right? Each of these were missing an electron beside each other. So far they've only made one bond, but they're still looking for those two doubled up pairs, okay? So what will happen is that those electrons will actually get together between one of the carbons and the oxygen. So what kind of a bond will this form? A double bond. Okay? We'll call it a super stacker. Okay?
Why are one side of carbon X over O?
I know, sorry, I misdrew it. It doesn't matter though. How about that? There you go. Okay, it's the same thing. Matthew, don't even. Okay, so on the other side, because there's 4 electrons there as well, what kind of a bond will we have between the carbon and that oxygen? A double bond, okay? So this is what carbon dioxide actually looks like. It has a multiple bond between the carbons.